Welcome to this comprehensive guide on C-sharp properties, a fundamental concept for any aspiring developer. We will explore how properties significantly enhance code readability, improve maintainability, and enforce proper encapsulation within your C-sharp applications, laying a strong foundation for object-oriented programming. In C-sharp, properties provide a flexible and safe way to access private fields, acting as smart fields that encapsulate data. This controlled access is crucial for object-oriented programming, allowing you to manage how data is read and written, protecting the internal state of the objects. Encapsulation, a core principle, means bundling data and methods that operate on it within a single unit. This restricts direct access to an object's internal components, safeguarding its integrity. It ensures the object state is modified only through predefined, controlled interfaces, typically using properties. Properties empower us with precise control over how data is set and retrieved within the classes. This control is vital for implementing validation engine, preventing invalid values, and ensuring data integrity. For instance, you can ensure an age property is always used. Now, let's begin our deep dive into C-sharp properties by first understanding auto-implemented properties. These represent the simplest and most straightforward form of properties, designed for scenarios where minimal custom logic is required, making them incredibly common in everyday development. Auto-implemented properties offer a concise syntax for declaring properties where no additional logic is required in the get or set accessors. The compiler automatically handles the private backing key, leading to much cleaner and more readable code by reducing the overhead. One of the greatest advantages of auto-implemented properties is that the C-sharp compiler automatically creates a private backing key behind the scenes. This significantly reduces boilerplate code, resulting in cleaner, more compact, and easier to read code. Consider this simple example. Public and age get set. This single line declares a public property named age of type integer. The get set syntax means it is both a get accessor to retrieve the value and a set accessor to assign a new value. The general syntax for an auto-implemented property is access underscore modifier type, property name get set. Access underscore modifier defines visibility. Type specifies the data type, and property name is its identifier. Omitting the set accessor creates a read-only auto-implemented property. Utilize auto-implemented properties when you don't require custom logic for validation, data transformation, or notifications upon value changes. They are designed for direct data storage and retrieval, offering maximum simplicity and efficiency where additional processing is unnecessary. Auto-implemented properties are ideal for simple data storage patterns, such as holding a user's first name or an item's class. Direct assignment and retrieval of values are perfectly sufficient, making them the go-to choice for straightforward data representation within the classes. Next, let's delve into expression-bodied properties, a more modern and concise way to define properties, particularly those involving simple, singular meaning. They offer syntactic sugar that can make your code even more readable and compact, especially for computed properties. Introduced with C under sys, expression-bodied properties allow developers to define property accessors using a lambda expression, specifically the equals operator. This makes property definitions remarkably compact and expressive for single statement measure. Expression-bodied properties are particularly useful for read-only properties where the value is computed or derived dynamically from other existing fields or properties. For instance, do not calculate a full-name property by concatenating first name and last name. Let's look at a practical example. Public string full name equals dollar first name dollar last name. This read-only property uses string interpolation to dynamically combine first name and last name. The equals syntax indicates the value is calculated on demand and accessed. The concise syntax for a read-only expression-bodied property is access underscore modifier type property name equals expression. Access underscore modifier specifies accessibility. Type is its data type, and property name is its identifier. The equals operator points to the expression that defines the value. For properties with both a getter and a setter, you can use expression bodies for both accessors, like get equals underscore value, set equals underscore value equals value. Here, underscore value is a private vacuum field, and value represents the incoming value being assigned. Expression body properties are best suited for simple, single-line logic or straightforward computations. Avoid overly complex operations within them, as this can significantly reduce code readability and make debugging challenging. Prioritize clarity and maintainability. Expression body properties truly excel for creating computed properties, where the value is consistently derived from other existing data. This guarantees the property's value is always up to date and accurate, eliminating the need for manual updates or synchronization logic. Finally, let's explore read-only properties, a critically important concept for building robust C-sharp applications. These properties are essential for creating immutable objects, whose state cannot be changed after creation, ensuring data integrity. A read-only property's value can only be assigned during object initialization or within the class's constructor. This strict limitation ensures that once an object is fully constructed, its read-only properties remain constant and cannot be altered later, providing stability. This enforced immutability ensures that once an object is created, critical properties cannot be inadvertently changed. This makes your code significantly more predictable, as you can always rely on the value of a read-only property remaining constant, leading to more robust applications. One of the simplest ways to create a read-only property is by leveraging the auto-implemented property syntax, but simply omitting set accessor. By removing set, you explicitly declare that the property can only be read, not written to, after its initial assignment. For instance, consider public GUID ID get. GUID stands for Globally Unique Identifier, used for unique object identification. This ID property is read-only, meaning its value can only be assigned once, typically within the class's constructor. Alternatively, you can employ a private setter, as shown in public string name get private set. This allows the property to be read publicly, but its value can only be modified internally by code within the same class. This provides controlled mutability. Read-only properties are invaluable for constructing immutable data structures, especially in multi-threaded environments. By ensuring data cannot be changed after creation, you effectively eliminate race conditions, where multiple threads attempt to modify the same data simultaneously. This makes concurrent code much safer. Read-only properties are perfect for representing data such as unique identifiers, configuration settings, or any information that should not be altered once an object's initial state is established. Data that the user's creation date or a product SKU, once set, remains constant. Having explored auto-implemented, expression bound, and read-only properties, it's now time to review some essential tips and best practices. Adhering to these guidelines will enable you to work with C-sharp properties effectively, leading to higher quality and more maintainable. A fundamental best practice is to always choose the simplest property type that meets your current requirements. Begin by defaulting to auto-implemented properties with straightforward data storage. Only introduce additional complexity when there's a clear need for specific behaviors. When the property requires specific validation use, custom data transformation, any other complex logic, utilize full properties. These involve explicitly declaring a private vacuum key, and then implementing custom get and set accessors, allowing you to insert any necessary logic. It's crucial to remember that properties are typically public members of your class. Therefore, their names must strictly adhere to standard C-sharp naming conventions, which dictate the use of Pascal codes. This means the first letter of each word in the property name should be capitalized. A critical guideline for clean code is to strictly avoid embedding overly complex logic directly within property accessors. Properties are intended for simple data access. If the logic becomes too involved, it's a strong indicator that this logic should be refactored into a separate method. Actively leverage read-only properties to rigorously enforce immutability within your objects, particularly for any data that should remain constant and unchangeable after the object's initial creation. This practice significantly enhances the predictability and safety of the object. Expression body properties are an excellent choice for defining computed values, especially when the calculation is simple, concise, and does not necessitate an explicit vacuum. They provide a clean, one-liner syntax for derived values. Ultimately, when designing your classes, always thoughtfully consider the precise purpose of each property. Ask yourself, does it need validation? Is its value computed? Could it be immutable? Choose the most appropriate property type for optimal code design. By diligently mastering the distinct property types, auto-implemented for simplicity, expression body for concise computations, and read-only for immutability, you will elevate your C-sharp programming skills. This mastery will empower you to write more robust, readable, and maintainable C-sharp code. Thank you immensely for joining us on this comprehensive exploration of C-sharp properties. We hope this guide has provided you with a solid understanding of their types, uses, and best practices. Remember, the key to true mastery lies in consistent practice and continuous building. Happy coding!